Welcome to PreStressed Concrete, Session 7 in the Kentucky Transportation Cabinet Structure Inspection online class. So before PreStressed Concrete, we had reinforced concrete bridges. You see a lot of these driving down the interstate, the reinforced deck girder bridges. Some of the downfalls of these were the limit of bar spacing requirements in the design, and one, the big high cost of formwork. I can't imagine having to build one of them reinforced deck girders with that curve and getting that right. One of the other problems was the depth of the beam. When you had that big curve in the deck girder, I know one of the issues we've ran into in some of the interstate widening jobs is height restrictions with semis having to be kept off the shoulder and for traffic control issues because of that limitation. And also, concrete is 10 times stronger in compression than in tension. So with pre-stress, we can kind of flip that. Also, reinforced concrete cracks as the reinforcement takes attention. So as we're looking, shifting more to pre-stressed concrete, we can get rid of that cracking. So why pre-stressing? If you see from the diagram here, this curved line equates the pre-stress strands. So as the concrete is placed and they build the beam, and then they release the pre-stressing strands, it draws the beam up, adding compression to this bottom side of the member, which would typically be in tension. And then as weight is loaded or force is added to it, it pushes down on the beam to equalize the stress of the compression in tension, which gives you a longer strength and being able to give you greater spans. So the typical beams we use in Kentucky. Here you can see the AASHTO Type 2 is shown. They've got a smaller top flange than the bottom flange. This is the top flange. This is the bottom flange. All of our types 1 through 4 are similar, just some variations in height and width. And then you go to the AASHTO Type 8 shown here, which are 5 through 7 are similar as well. They've got a narrower top flange, which is wider than the bottom flange. Some of the typical beams in Kentucky, we use a lot of box beams. Here's a box beam shown that's 12 inches in depth by 4 foot in width. That is a pretty standard beam we use, but our box beams can vary from 12 inch thick, 17, 21, 27, 33, and even 42 inches thick. The 12 inch beams are going to be solid, while you get up into the 42 and some of the thicker ones, you're going to have a hollow inner core. Like I said, typically our box beam is 4 foot wide, but with Bridging Kentucky and getting a lot of these designs out and getting some different widths, we've been gone to a 3 foot wide beam. These are still kind of rare, but you're starting to see them more and more. Some new beams we got are our hybrid beams. These beams have an extremely wide top flange, 61 inches to be exact. We built one of these bridges in Jefferson County, and after the beams were set, it literally looked like you could just drive a car directly on top of them. There was very little room in between the beams to even set the deck pans. But these can give you great spans. The ones we built in Jefferson County, I think, was a 142 foot span from the pier to the indent. So they give you that distance to span and reduce the number of piers, which then reduces the concrete, foundations, and everything else, which reduces cost. So some of the limitations with pre-stress. The max span in Kentucky is between 160 and 165 feet. I think it's around 162 feet, and that is in Bourbon County. In Kentucky, we use a max compressive strength of 8 KSI. That is due to the limestone aggregate that we have. It's a pretty good aggregate, but 8 KSI is about what we can get. The record simple span for a pre-stress beam is 223 feet. This is in Tacoma, Washington, and it was designed with 10 KSI lightweight concrete. You may ask, well, how come they're designing at 10 KSI and we're designing at 8? Like I said, our 8 comes directly from our limestone. Out there, they're using a granite, which the granite is stronger than the limestone, so therefore they can go up to a higher strength. You may ask, how can you get a span like that? Well, just think, if this is a design right here, you've got 30 cables, pre-stressed cables in this beam. Each one of those cables is stressed to 33,000 pounds. You total that up, you get almost 1 million pounds of force that are going to be on that beam when they release that. All right, so enough with the design. Let's move into pre-stress beam placement. One of the biggest things on a job, you've got your substructure built, you're ready to start building the superstructure. So before beams ever get there, what are you going to do? What is your role as the inspector? You want to look over the guidance manual. Go to the session on bridge beams and setting them. They will kind of walk you through what to expect. Have your plans. Make sure you've looked at the framing diagram. You understand the placement. You understand where they're going to be. And then also look over the approved shop drawings. These shop drawings are going to tell you how to set it, how to pick it, what needs to be done in the beam setting plan. They will walk you through the lift procedures. Also go look at specification 605, 03, 09. This is going to walk you through everything that's required for the Kentucky specs. And again, go to the standard drawings. They're going to be one of your best friends when building a bridge because it has a lot of things that are similar with every bridge. Here you're going to look at beam details, bearing pad details, box beam bearing and box beam leveling details if you're doing a box beam bridge. But the bearing pads are critical because that's what the beam sits on. We're kind of going away of using the lead plates and the cork. I still see one out there every now and again, but mainly it's these elastomeric bearing pads. Check those out. Make sure you understand what's going on with those and placement. So transporting the beam. The beam comes in. You can see the tractor trailer bringing it in with a dolly on the back, all the cables. Depending on the length, you really got to find a good route. That's up to the contractor and the fabricator. That's not on you, but you need to know as the inspector what route are they bringing them in so you can make sure everything is safe. They may have to do some shoulder widening, road widening, but make sure it's done and they can safely bring the beam to the job site. So when transporting the beam, one of the biggest things is the beams must remain upright at all times. We don't want to be laying these down. They don't have any strength on their side. All their strength is when they're standing vertical. If you lay them over, they're very susceptible to damage during transportation. The beams need to be supported at all times during storage, lifting, and transporting at only 2 points. These are usually designed at the ends. During lifting and transporting, each point shall be not farther from the end of the beam than the depth of the beam. So if you've got an 8-foot beam, which is a big beam, we'll just say a 4 foot, then you cannot have your lifting points any further than 4 foot from the end of the beam. See the shop drawings for further detail. They're going to show you where those lifting loops can be, and just make sure you're following that. During storage, points shall be not farther from the end of the beam than 1/3 the depth of the beam. And this is key to make sure if it's going to be set on a skew, you store it on a skew. If it's straight, store it on straight. We've had some issues with some cracking because they weren't stored correctly. So your field inspection checklist. What are you looking for when beams arrive on site? The first thing is you want to find that Kentucky oval. Here you can see it in blue. I've seen it in black. I've seen it in green. But make sure it's the circle or it's the oval with the Kentucky initials on the inside. If it doesn't have that, the beam doesn't get unloaded off the truck. Start making phone calls immediately. That KY oval represents that our materials representative approved these beams at the fabrication shop saying everything was good. If it doesn't have that, that means we haven't looked it over before it came. Length. You want to verify the length. If it's supposed to be 112 foot long, get a tape out and verify it's 112 foot long. Check the sweep. So sweep is a side to side. Say you're in a horizontal curve. You might have some sweep due to elevation, super elevation of the roadway. Check it. Is that there? Is the camber there? A lot of times you might see a range of camber, say from 3 to 7 inches allowable. Check it. See what it is. The longer beams stay in the storage yard, the more camber they will generally gain. So if you've got beams that have sat for a while, you could get excessive camber, and then excessive camber leads into the thickness of your deck. If it gets too much camber, you might not get your 8-inch deck as we're designed. That's something to look for. Also, if you don't have enough camber, you might have a deck that is too thick. You might getting into a 10-inch deck, which could run into some dead load issues. So check the camber to make sure you know what it is before it ever comes off the truck. Check the bearing area. See where it's going to sit on the pier. Make sure everything is good. If it needs a sole plate, it has the sole plate. If not, just check and make sure as per the shop drawings. Check for cracks. You don't want to see any cracks. The only place you might see a few that are acceptable is the end, but still, if you see them, raise a flag, Ask questions. Understand what's going on. If you've got a mid-span crack, you definitely don't want it off the truck. And also check for your stay-in-place decking angles. As you can see here, all these little squares drawn on this girder or beam, that is your angles. Right here, there's 96. That's metal clips, 12 gauge. There's 95 of them spaced every foot. These are for the angle iron to get welded on there to set your stay-in-place decking. Make sure they're there. Also, for your exterior beams, you want to make sure you got your overhang hangers. Right here, these were designed at 4 foot. Typically, you want to see your overhang drawings come in before the shop drawings for the beams, because those overhang drawings will determine the spacing of these hangers. Finally, check the specifications for all your dimensional tolerances. Check that in the spec book. That'll kind of make sure you've got everything you need. So question, think about this. You're the inspector on a small bridge project. The pre-stressed type 4 beams arrive on the truck and you notice cracks in the mid-span of the beam. You think, they're small cracks. They're no larger than a 16th wide. Is this okay? No. Think back. If you've got any cracks mid-span, something's gone wrong in the pre-stressing and getting that, because if you see cracks, you're more likely in tension. We don't want these in tension. That's what the pre-stressing is doing, is to keep that bottom in compression. So bearing pads, these are identified on the plans. I've kind of talked about these already. They are delivered with the beams. They're not coming out early. The pre-stress manufacturer is not making them. They're buying them from someone else, but they will get delivered with the beams. Check against the plans and the standard drawings to make sure that you have the correct pads. You're looking at the shop drawings, you're looking at the standard drawing. Make sure the contractor has laid them out before they ever come out on site. They'll use some chalk or a pencil to kind of draw in exactly where they need to be placed. So what are these bearing pads? So we're using elastomeric bearing pads. They're designed to support the vertical compressive loads. So as the beam sets on it, it is supporting that. It kind of evens it out to eliminate any point bloating, and it kind of really spaces and distributes the load from the beam. They also allow for horizontal movement of the beams due to thermal expansion and contraction. That's your biggest one. As it gets hot and cold, the beams are expanding and contracting with the deck. And a lot of our integral indents, we're saying we want this to go with it, and at the pier, it allows that movement. They also allow movement for traffic loading, elastic shortening, beam end rotation, and time-dependent changes in the concrete. But just note, they allow that movement. So bearing pads are laminated neoprene bearing that are preferred. If you get in to where you need to level it, make sure any shims are placed on top of the pad. These will help compensate for any slopes that might be across the bearing pad. If you get into issues, especially in box beams, where you got to level it to even out your top, you've got to make sure you got these steel shims. Here's a good picture of one we just installed down around Bardstown. We replaced an old rocker bearing assembly on this bridge, and you can see the neoprene pad is right here with a steel plate assembly on top of it. This is welded to the sole plate that's on the end of the girder. But this is a way where we're retrofitting an old job of a rocker that got rusty and corroded and we couldn't be used no more, so we need to retrofit to this. But it's still the same. You got the steel shims inside of here, coated in the rubber to hold everything together. So your layout, like I said, the contractor needs to do this before beams show up. So you're going to see they will come through and they'll use a carpenter square and whatever else they need to get this laid out, to have that bearing area prepped, and then they'll place the cork or the foam or whatever is required in the other spaces. It takes a lot of good deal to get this done, some thinking involved. So if you need to work with your contractor, work with them, and don't be afraid to ask questions. So in beam placement, don't cut any lift strands until the beam is in its final position. Usually the contractors aren't going to cut them until they get all the beams in and get their diaphragms in place, but make sure. Make sure beams are properly seated and there is no point bearing. It's a good thing about these elastomeric bearing pads. You're really getting away from the point loading, but some of the old lead plates with cork, you really had to make sure you had a good flat surface there or whatever elevation needed for the beam. This could entail some grinding or something else, but make sure you don't have any point loading. Brace the beams before diaphragms are placed. Usually this is done by just holding with a crane until they can get the diaphragms in place. But if it's an exterior beam, you're going to have to hold it while you're setting your second beam to be able to lock them together with the diaphragms. A great deal of precision and communication between the crane operator and the worker is critical. They have got to make sure this beam gets lifted. As you can see, we got traffic on one side, traffic is closed on this side. They're going to lift this beam into place. This guy right here is going to be communicating with the crane operator up, down, left, right to be able to get it to sit in place. Here is an exterior beam. These should be supported in some way to keep them from falling, especially with live traffic going underneath it, until the second beam gets placed and you can lock the two of them together with the diaphragms. So you brace them until all diaphragms are installed. Here you can see the diaphragms are installed. We've got all 4 beam lines in. They've installed it. Usually you'll see them swing them into place with the diaphragms installed on one. That way all they got to do is hook them up on the other. It's just time saving. That's a contractor preference. Here you can see the safety cable that's on here with the overhang jacks and the metal clips for your stay in place forms. So you've heard me mention diaphragms. You may not know what that is. Well, the diaphragms are these steel members used to connect the beams. A lot of it is, it's just to support them until the deck gets poured. Then the deck will distribute the loading between them, but they're critical to make sure they're in with high strength bolts and washers and DTIs. We have some that are just a channel like this, and then we have other one intermediates that are these cross bracing like this. These are typical for no skew bridges. So if you get into a skew, you're probably going to get the channels. Here is the plan for what a PPC I-beam type 4 should be like. So this, the contractor is going to send out to their pre-stress manufacturer to get shop drawings back. The shop drawings are going to have to meet this sheet. This is good detail. Make sure you read the general notes. This is usually going to be between 15 and 20 in your bridge plans, somewhere in that sheet number. But check it. Your biggest thing you want to look for then is at the shop drawings, because they're going to detail everything you need to know about the beam and placement. So here are some that have been placed. We've tied steel and got our deck pan set, but I like this picture just because you can see the stay in place angle clip here was cast into the beam. Here are lifting loops that have been cut and touched up with epoxy paint. So anything that gets cut or in the deck must be galvanized, stainless steel, or epoxy. And then here you can see one of the overhang hangers that are used for our exterior overhangs. Another good picture, you can just see this clip right here as well as the angle iron here. But with this, you see these stirrups. They'll come out on the beam. These need to extend into the bottom mat of steel to make sure we have a composite deck. We want to lock the concrete of the deck into the concrete of the beams to make them act as one. Those stirrups are what's there to make sure they work as a composite member. Absolutely no drilling into the beams. You can see here, this hanger was cast into the beam at the precast manufacturer, but the contractor didn't like it and they wanted to move it. So they drilled a hole in here, put an anchor in, and then put their overhang jack on there. That's a no-no. Just think, that strand and that top mat were stressed at 33,000 pounds each. If they're drilling in and they break one of those strands, what's going to happen? We don't want to get into that. So your first response should always be no drilling into the beams. If it does have to get done, then we'll call the pre-stress manufacturer, get their recommendation. But there are other things they can do. They make hangers that hang on top of these stirrups and off the side of them that they could use here, but drilling was unnecessary in this instance. So make sure your first response should always be no drilling into beams. So let's move into box beam bridges. It's very common in the state of Kentucky. You got two different kinds. You have composites and non-composite. Composite are side-by-side beams with a riding surface. That's either concrete or asphalt. More than likely for the state, we have gone to a 5-inch concrete overlay, but some county bridges might still be asphalt. And then your non-composite decks, which are side-by-side beams without a riding surface. So you're actually driving on top of the beams. You'll see a lot of older bridges in place like this, and even some county bridges built nowadays, but as far as a state bridge, we have kind of gone away from these non-composite bridges. So here's a picture of a non-composite bridge. You can see on top of the beam is the riding surface. They have sealed these joints and they've paved up to it. Composite bridge, you can see the beams here with the riding surface, this 5-inch slab on top. Here's a picture of one that just got built up in Grant County. As I said, you can see the KYTC oval on there saying these were approved. You can see the grout in between them. And notice you might say, hey, that's a little bit of vertical difference in between that. You're right. That can be accounted since we're doing that 5-inch minimum deck on top. You can adjust your deck height to make sure you account for that to get that minimum 5-inch concrete deck. So precast pre-stressed box beams require grout. So whether at the fixed ends or the tension rod blockouts or in the keyways, it requires grout. The notes will require what kind of grout that is. That's in the standard drawings. And if you read that, it's got to be a non-shrink grout. So as an inspector, what's a quick way to know if it's non-shrink grout or regular grout? The easiest way is non-shrink grout only comes in a bag. They have to mix it on site. So if the contractor shows up and has a ready mix truck show up and say we're ready to grout these, you know right then and there that is not non-shrink grout and it shall not be used on one of our bridges for these anchor spots, shear keys, or tension rod blockouts. All this grout has to be done after lateral tension rods have been fully tightened and before any leveling devices have been removed. We want to make sure everything is locked together before we put the grout in to seal it off. The cost of this grout is incidental to the price of the box beam. So here's a detail for the leveling device. Let's zoom into that detail. If you look at it, this is in the non-composite bridges because the top has to be smooth. Composite decks, we're not getting into that as much because we're putting a deck on top of it, locking it all together. But if you do have a non-composite bridge, refer to this leveling detail and make sure they use this to get them level on top. So I mentioned earlier the lateral tension rods. These are these lateral tension rods right here. They lock each beam together. If you see here on a skewed bridge, they've got to lock them each beam once they get put in because of the skew, but on a straight bridge, zero skew, they can put one tension rod throughout, lock them together, fully tension them. Up here you can note they must be tensioned to 20,000 psi, developed by a torque wrench of 200 foot-pounds. We've got to make sure that they're getting that in. The tension rods are designed with a keeper plate, a washer, and a nut. These get fully tightened. These are now a galvanized or stainless steel material, and then you do the non-shrink grout in the ends to lock it and seal it all up. Another detail, the lateral tension rods getting placed in on a non-skew bridge. What I want you to note here is if you've got a box beam that has a hollow core, you're going to see these void drains. Make sure the contractor doesn't fill them in. We don't want spray foam in them. We don't want grout in them. These are used to drain the box beam in the instance of you've got a creek that kind of floods and you might get some water in there. So your bearing details, make sure you note where these bearings go. I've seen them where the bearing goes in between and supports two beams or right in the middle. Note your bearing details on the standard drawings and the plans. That bearing must be correct because this dowel gets drilled into the substructure after beams are placed. We don't want to be doweling into one of our elastomeric bearing pads. As you can see here, there's the bearing pad. Here's the end of the beam. This is on a pier cap section. This is epoxy coated dowel, gets drilled in after the fact. Let's look at this one to see that. So here you can see the bearing pad is in with the cork. The dowel comes with a 3-inch hole in the beam, and then they drill that into the concrete substructure, whether it's fixed or non-fixed. It still gets drilled in and epoxied into that. Then you need to know, is my end here fixed in or is it expansion? At a fixed end, you grout it, non-shrink grout. At an expansion end, use a hot pour crack and joint sealer to give it to be able to move without cracking. So that's an elastic Merrick hot pour system. So let's do a review of box beams. Make sure you know which end is fixed and which end's expansion. If you don't see it on your plans, ask a question. Check with your engineer, check with the designer, figure out where it is. Leveling is very important, especially a non-composite bridge. Like I said, you don't want any offset, vertical offsets there. Make sure you get them level. In that leveling, you might need to put metal shims on top of the bearing pad to account for that leveling. And then finally, make sure you patch the tension rod blockouts and lateral joints between the box beams with a non-shrink grout. Especially on the ends of the beams, that tension rod blockout, if that doesn't get grouted, that affects our rating when it comes to actually getting the bridge inspected. Here's a picture of the tension rods, the wrench holes that have been grouted with a non-shrink grout. Here you can see the keyway is grouted, and here you can see the stirrups being ready to tie in to make this a composite deck. And that's it for the pre-stressed concrete session of this class. I hope you've enjoyed it. Like it, share it, and I hope to see you in class one day.